Welcome students. Our topic is matrices. What is a matrix? The mathematical definition is it is an ordered, I'm writing the terms, it is an ordered rectangular array. So it's ordered rectangular array of numbers or functions. Okay, so this is the mathematical definition. A matrix is an ordered rectangular array of numbers or functions. What is the meaning of this? Let's say I'm writing simultaneous equations of with three variables. Let's say a11 x plus a12 y plus a13 z is equal to d1. Then a21 x. So we have three equations. We have three variables x, y and z, and we represent these simultaneous equations like this. We can represent it in a more ordered way by use of a matrix, and by the mathematics of matrix we can solve this equation also in a very neat and clean way. So how do we represent this as a matrix? You just note this down. So what we do, we say that let a matrix A be like this, where we have all the coefficients of x, y and z. So this is a11, a12, a13, that is the coefficients of the first row. Then the second row is a21, a22, a23, and the third row is a31, a32, a33. So if we represent it like this, it becomes very neat and clean. We can directly see what is the coefficient of of y in the second row, in the second equation. It is a22. So this is a way to represent it, and we use this capital bracket. This is the sign of the capital bracket. So this is now a matrix. I'll tell you what is the use. First of all, let's understand how we represent it. So this is clear. I'm rubbing it. So instead of those three simultaneous equations, we can simply write this what we wrote just now: a11, a12, a13, a21, a22, a23, a31, a32, a33. This is our variables x, y, z, and this is in the right hand side. It was d1, d2, d3. So that set of three simultaneous equations can be represented in matrix form like this. This is a matrix which represents the variable. This is a matrix which represents the coefficients in the RHS, and this is the matrix that represents the coefficients of the variable x, y, z. How this is processed, that is our subject of study, that we'll know later. For now, you should understand that this is how we represent a matrix. Okay. Now from this only you can see that this has got so many rows, so many columns, but this has only one column. This also has only one column, but all of them have three rows. So what I'm trying to do, I'm trying to introduce you the terminologies. This is called a row. Okay, so here also we have one row, two row, three row, one row, two row, three row, and this is called columns. We have 1, 2, 3 columns in this matrix. We have only one column in this matrix and one column in this matrix. Clear? What we do, the number of rows we write as m and number of columns we write as n, and we say that the matrix is m cross n matrix, which is called the order of the matrix. Clear? Now I am introducing a new term, order of the matrix. The order of a matrix is m cross n, where m is the number of rows and n is the number of columns. So this is a 3 cross 3 matrix. This is 3 cross 1 matrix. This is also 3 cross 1 matrix. Let's say we want to see a 1 cross 3 matrix. 1 cross 3. This will be A, B, C. This is one row but 3 columns. 1, 2, 3. So this is the order of the matrix. This is called row, This is called column, and the individual entities that you see, they are called elements of the matrix. Clear? These all are elements. This. Every entity inside the matrix is an element of the matrix. Now this is called the diagonal of the matrix. A11, A22, A23. This is the diagonal of the matrix. What is the use? We will be seeing later on. We also write matrix like this, Aij. This is also how we denote a matrix. A matrix A can be written as Aij, where I is the number of rows and J is the number of columns. So I will write between 1 to n, because we have m cross n matrix. So the number of rows can be at the most m, and J lies between 1 and n. Clear? So this is also a representation of matrix. Now let's see the type of matrices. We have several types of matrices. So types of matrices. This is our topic. First is called a row matrix. What is a row matrix? In our Aij, this is row. So we'll have only one row. That is A1j. If we have matrix like this, A is equal to this, then it is a row matrix. That is, we only have one row. A, B, C, whatever be the number of columns, we have only a single row. That is called a row matrix. Similarly, we have a column matrix. That is, we only have one column. We saw two column matrices in the last example. So, column matrix will be like AJ1. Not J, we denote it as I. So, AI1s. That is, the number of columns is 1. Like we saw X, Y, Z. Or we saw D1, D2, D3, let's say 7, 8, 9. So these are column matrices. Clear? Then third is called square matrix. What is a square? When the number of sides of a rectangle, when all the sides of a rectangle are equal, that is a square matrix. Similarly, if n is when n is equal to n. Then we have a matrix called diagonal matrix. See, diagonal matrix. From the name only, it is clear that it has something to do with the diagonal only. So when all the non-diagonal elements are 0, it is a diagonal matrix. Let's for example take 2 cross 2 matrix. Let's say this is 2 and this element is 3 and this is 0, this is 0. That is, we have non-zero elements only on the diagonal, others are 0. For example, I am taking a 4 cross 4 matrix. 2, 0, 0, 0, 0, 3, 0, 0, 0, 0, 5, 0, 0, 0, 9. So, this is a diagonal matrix. We have non-zero elements only on the diagonal. And one more thing to remember here is that diagonal matrix, we get diagonal matrix only in case of square matrix. Clear? If you have a column matrix, you won't get a diagonal matrix. Only when we have a square matrix and all the non-diagonal elements are 0, we call it a diagonal matrix. Clear? Now, within this matrix, that is diagonal matrix, if all the diagonal elements are same, that is, let's say if this was all the elements were 2, 2, 2, 2, or here we had 3, 3. So this is a diagonal matrix. First of all, it is a square matrix. Both of them, they are a square matrix. All the non-diagonal elements are 0, and the diagonal elements are of the same magnitude. They are equal. That is 3, 3, 2, 2, 2, whatever it be. That's not 6, this is 0. Okay. Then in that case, we call that matrix as scalar matrix. So this is our fifth type. Clear? Very simple. Now we will see our sixth type, that is called identity matrix. It is a scalar matrix in which all the diagonal elements are equal to 1. So this is our sixth one, identity matrix. Identity matrix. So what is it? It is a scalar matrix. Scalar matrix. This means this is a diagonal matrix and this means this is a square matrix. So if all the diagonal elements are equal to 1, this is called an identity matrix. So it is a square matrix. All the non-diagonal elements are 0, therefore, and all the diagonal elements are same. So it is scalar, and when all these elements are 1, it is identity matrix. So in an identity matrix, what you will see? You will see all the diagonal elements are equal to 1 and all non-diagonal elements are 0. So let's say for 2 by 2, this will be like this. For 4 by 4, it will be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So this is 4 cross 4 identity matrix. Clear? Now seventh type is called zero matrix. Zero matrix, or it is also called null matrix. Null matrix. If all the elements are 0, that is a zero matrix. For example, 0, 0, 0, 0. It is a zero matrix. Clear? Or single 0 or 2 zeros. So whatever it be, if all the elements are 0, that is a zero matrix. Clear? We'll see one more matrix, the eighth one, that you won't find in your elementary book, elementary textbook. But if you go a bit beyond your textbook, you'll find one more matrix that's called submatrix. A submatrix is found by omitting a few columns or a few rows or both. Okay, so what I mean by saying, if this is A, B, C, X, Y, Z, K, L, P, let's say we have this as a matrix. Okay, let this be matrix A. If we omit column 1, what we'll get? We'll get B, C, Y, Z, L, P. So this is also a matrix. Let's say this is B. Then B is a submatrix of A. Okay. Or we can omit this last row. What will get? A, B, C, X, Y, Z. Let's say this is matrix X. So this matrix is also a submatrix of this. Let's say we have matrix B, C. Let's say this is Z matrix. Z matrix is a submatrix of B, and it is also a submatrix of A. We have omitted column 1 and we have omitted row 2 and row 3. We get this. So this is submatrix. Yeah. Okay, and every matrix is a submatrix of itself. How? By omitting no rows, no columns. So if we don't omit any row or column, we get A, and that is every matrix is a submatrix of its own. Clear? So now we have seen different types of matrices. Now we'll start operations on matrices.